Hello everyone. Today we will learn memory organization related to computer architecture and organization subject. The memory consists of two major types. First one is internal memory and second one is external memory. We will go for one by one. Today we will see internal memory first, then later on external memory. Now, when we talk about internal memory, basically the internal memory is made up of semiconductors. Sometimes it is also called as main memory, and semiconductor chips are used to store data. So the basic element of the semiconductor memory is called as memory cell. So if you look at the diagram which is shown below, you can see that we can provide two different states for that memory cell, which is in binary 1 and 0. Now they are capable of being written into to set the state, or they are also capable of being read to sense the state. So we can set a state also and we can sense the state also. Now each cell has three functional terminals capable of carrying an electrical signal. Now the select terminal selects a memory cell for a read and write operation. So if I want to select a particular cell, I will use this terminal for selecting, for read and write purpose. Whereas the control terminal indicates read or write operation. So whatever operation I am going to do, I will indicate using this control terminal. The remaining terminal provides an electrical signal that sets the state of the cell to 1 or 0. So this data, in what it does, basically it sets a value of 1 or 0. For reading, that terminal is used for output of the cell's state. So similarly, in order to read also, I am using the same terminal as an output of that cell state. Now when we go for main memory, the main memory is been categorized into different memory types, and most of the famous one is RAM, which is also called as a random access memory. It has particular characteristics. The RAM can possibly be both, that is read and written to the memory at the same time, and it can be implemented easily and rapidly. RAM is volatile in nature. That means the power supply should be continuously provided in order to read the data or write the data. And RAM can be categorized into static and dynamic. So we will see the two types of RAM one by one. Before we go for RAM concept, let's see how many memory types are there. The first one is random access memory, as we just now talked about, so which is read and write memory category, and electrically I am reading and writing things, so it is volatile in nature. If the power fails out, the data gets deleted or erased. Later on, remaining are the ROMs, which are also called as read only memory. Now that can be programmable, that can be erasable, and different kind of erasable is electrical erasable and flash memories. So we will see this one by one as we move on in this topic. So let's concentrate first of all on the random access memory. Now in random access memory, the first one is dynamic RAM. Dynamic RAM is also called as DRAM. So DRAM is made with cells that store data as charge on capacitor. So basically we are using capacitor in order to store the charge. The presence or absence of charge in a capacitor is interpreted as a binary 1 or 0. So interpretation is depending on to the charge in the capacitor. The term dynamic refers to the tendency of the stored charge to leak away. So dynamic, why we are saying it as a dynamic RAM? Because the charge which is stored in the capacitor, that leaks depending on to the time respect. So as the time passes on, the charge gets leak, we need to recharge that capacitor periodically. So let's see the construction of DRAM and understand. Now the figure shows a typical DRAM structure for an individual cell. So a single cell can be having such kind of structure that stores only one bit of data. Now the address line is activated when the bit value from this cell is to be read or written. So whenever I need to read it or write it, the data to this cell, this address line is activated. Transistors work as a switch. So this transistor works as a switch, that is, when it is closed, it allows the current inside of voltage is applied to the address line, and when it is open, there is no current inside or no voltage is applied to the address line. For write operation, a voltage signal is applied to the bit line. A high voltage represents 1 and a low voltage represents 0. A signal is then applied to the address line, allowing a charge to be transferred to the capacitor. For the read operation, when the address line is selected, the transistor turns on and the charge stored on to the capacitor is fed out, that is given outside onto the bit line and to a sense amplifier. Now the sense amplifier compares the capacitor voltage to the reference value and determines if the cell contains a logical 1 or logical 0. So as the capacitor stores the current, now here the current can be of having in an analog value. So in order to provide a better communication of whether the message or the data is 1 or 0, there is a threshold value which determines whether the charge is interpreted as 0 or 1. Now that threshold value is compared with the sense amplifier which receives the data from the bit line B. So in this way the DRAM cell works out. Now let's move on for the static RAM. Static RAM is a digital device. It is not analog like DRAM. The static RAM, that is SRAM, stores binary values using traditional flip-flops logic gate configurations. A static RAM holds its data as long as the power is supplied to it. Now it is not leaking similar to DRAM, but it is volatile because it also needs continuous power to be supplied. Okay. So there are properties like it is more expensive, it is faster in nature as compared to DRAM, and it is used as a cache for the system. We will see these things as we compare both the RAM types later on in further slides. We will see one by one. Now let's look at for the basic structure of SRAM cell. The figure shows the SRAM structure. 4 transistors are there, that is T1, T2, T3 and T4 are cross connected in an arrangement that produces a stable logic state. Now in logic 1, that is state 1, C1 is kept high and point C2 is kept low. In this state, T1 and T4 are off and T2 and 3 are on. In logic state 0, which is reverse of the logic state 1, point C1 is low whereas point C2 is high. In this state, T1 and T4 are on and T2 and T3 are off. Both states are stable as long as the direct current voltage is applied. Similar to DRAM, here the address line controls two transistors. So this address line controls two transistors, that is T5 and T6. When the signal is applied to this line, the two transistors are switched on, allowing a read and write operation. For a write operation, the desired bit value is applied to line B, where its complement is applied to line B dash. This forces the four transistors, that is T1, T2, T3 and T4 into the proper state, and the message is returned to the transistors and it is given to the capacitors. For read operation, bit value is read from line B only, so there is no involvement of line B dash. So in this way the SRAM works. If you compare DRAM and SRAM, SRAM has a little bit of more complex structure as compared to DRAM. Okay, so that is the basic difference between both the cell structures. Now let us move on for the SRAM versus DRAM. Let's compare both the RAM parts. Now you can see that both are volatile in nature. I required power supply for SRAM also and DRAM also. There should be a continuous power supply in order to preserve that data. Both are dynamic in nature. DRAM is simpler to build as compared to SRAM. It is quite simpler to build and it is smaller in nature. So I can put more number of cells in a given space as compared to SRAM, and I can provide those number of cells more in less expensive feature. Now the basic disadvantage in both the things is DRAM needs to be refreshed every time. SRAM doesn't need to be refreshed. Whenever you read a data from the DRAM, you need to refresh. Whether you are providing a write operation, then also you need to refresh in the DRAM. But whereas in SRAM, you just need to provide a constant power supply. So DRAM can have larger memory units, whereas static RAM, that is, it is not having larger memory units as compared to dynamic RAM. Static RAM basically resides near the processor because it is made up of flip-flops. So it can be residing onto the processor or near to that. And as it is involving flip-flops, it is faster in nature as compared to DRAM, and it can be used as a cache system, whereas dynamic cells are used as a main memory systems. So these are the basic difference between SRAM and DRAM. So that's all for now. We will see much more properties related to internal memory and how the error is being controlled over that in upcoming videos. Thank you.